hope we pray for better days.
Dear students, welcome back to today's Vidyanagar online science class. Today we are going to start a new chapter, Force and Laws of Motion. And also we will discuss the points like balanced forces, unbalanced forces, Newton's laws of motion, inertia and mass. Let's begin our today's class. Okay, we can start our new lesson with the concept of balanced and unbalanced forces. What are balanced and unbalanced forces? Okay, if you get the idea of balanced and unbalanced forces only, we can continue our chapter. For example, you consider the game tug of war. In tug of war, how many teams should be there? 2 teams, right? Okay, so during the game, if 2 teams apply equal force, during the play, if 2 teams apply equal forces, how we decide the winners? Is it possible for us to decide the winners? No. Then how we will find the winners in the case of tug of war? We can find the winner if one team apply more force than other, that team or the opposite teams move to their position. Their position means the team which apply more force. You may see that, they are doing like this. Okay, they are pulling the opposite team towards their side, right? So if they are pulling the opposite teams towards their team only, they can win, right? So pulling that opposite teams towards their team means the pulling teams, right? The pulling teams applying more force. Or another case you see, when you just consider a situation in which 2 students are, trying to push a table. 2 students are trying to push a table. If both boys apply equal force, is there any change in position for that table? Definitely not. If one boy apply more force than other, there you can see the table starts to move in the position there the more force, or it starts to change the position to the opposite side. Correct. So what is the idea you have to get from these examples? The thing you have to understand that if you want to change the position of an object, first we have to set up an unbalancing between the forces. If there is unbalancing between the forces, there you can see the movement of the object. Unbalancing between the forces means what? One is more and other is less. One is more than the other. So that is unbalancing. See, you may see in that water always flows from higher level to lower level, right? Water, the water falls from higher to lower. So there also higher, lower. So that is the difference, right? So if there is difference in the forces, there you can see the movement of the object, which means the unbalanced force on an object brings that object in motion. The unbalanced force on an object brings that object in motion. If there is unbalancing between the forces, you can see there is the movement of the object. Okay, so if equal forces are applying, in that case, the object does not change the position. If one side or one force is more than the other, there you can see the movement of the object. So the thing is that the unbalanced force act on an object brings that object in motion. So the unbalancing between the forces brings the object in motion. So this is very important point. If there is unbalancing or if there is difference in the forces, there you can see the movement of the object. If the forces are equal in magnitudes, there the object does not move. So that equal in magnitude is the balanced forces. So two forces are said to be balanced if the net force produced by these forces or these objects is zero. The unbalanced force produced by the two objects or the force is said to be unbalanced if the net force produced by these objects is zero, which means in case of balanced forces means simply you can consider equal forces, right? So if equal forces are there, is there any change in position? No, that is net effect is zero. Net effect is zero means what? Total effect is zero. Total effect is zero means the object does not move. So that is the effect here. So here the effect is the object does not move. So here that effect is zero. The effect is zero means what? The object does not move. Okay. If the forces are said to be unbalanced, if the net effect produced by the object is not zero. Not zero means object moves. Not zero means object moves. So if that effect is not zero, such forces are unbalanced forces. Such unbalanced forces brings the object in motion. If the net effect is zero, such forces are balanced forces. In case of balanced forces, the object does not move. If the object does not move, balanced forces. If the object moves, unbalanced forces. In case of unbalanced forces, net effect is not zero. In case of balanced force, net effect is zero. If the force is said to be balanced, the net effect produced by the object is zero. If the forces are said to be unbalanced, the net effect produced by this object is not zero, and the unbalanced force act on an object brings that object in motion, which means if there is unbalancing between the forces, there you can see the movement of the object. If there is no unbalancing, the object does not change the position, which means the case is balanced or the forces are balanced. So the unbalanced forces act on an object, changes the object in motion. Okay? Consider a situation in which two students are pushing a box. Two students are pushing a box. If these two students apply small force, the box does not move. Why? If these students apply small force, the box does not move, which means the box or the floor exert frictional force on the box. Have you heard about frictional force? What is frictional force? Frictional force is an opposing force. In case of a box, the floor apply a force on the box. So that upward force is frictional force. So because of this frictional force, object does not change the position. So what we have to do to change the position of this box? In the previous case, these students only applied very less force. That very less force is not enough to overcome the frictional force. Got it? So that small force is not enough to overcome the frictional force exerted on the box. That's why by applying small force, the box does not move. So we have to overcome the frictional force by applying a greater force, then you can change the position of an object or position of the box. So the only way to move the box by applying huge amount of force which overcomes the frictional force exerted on the box, which means you have to apply the force which is greater than or larger than the frictional force, then the box starts to move. It's very important point for you. On applying small force, the box does not move means that small force is not enough to overcome the frictional force. When you overcome the frictional force exerted on the box, you can change the position of the box. So, in order to overcome the frictional force exerted on the box by applying a greater force. So when you apply the force which is greater than the frictional force, you can change the position of the box. Got it? So if you want to change the position of the box, the way you have to do is that you have to apply greater force, or you have to apply the force which is greater than the frictional force. When you overcome this frictional force, only you can change the position of the table till the box does not change the position. So, if you want to change the position of the box, what these two students have to do, they have to apply a greater or more force which is greater than the frictional force. So, you know, the frictional force is very important in case of an object. If an object, you know, situates in their own position, or why, you know, when I am standing, why I am not falling, or why I am not, you know, falling, because that is due to the frictional force between my body and the floor. So, why, you know, you have studied last year, you know, while we are writing on the board. So, which force help us to do that? That is frictional force. So, frictional force is good for, you know, in some cases it is good, and in some cases it acts as a bad, right? So, that and all you studied last year. So, the thing you have to get from that, you know, in the previous case that students only applied very less force. That less force is not enough to overcome the frictional force. If you want to change the position of the box, you have to apply the force which is greater than the frictional force. Then you can see the change in position of the box. So this concept is very important for you. If you want to change position of any object, not the box or any object, you know, if you want to change the position of any object, you have to apply the force which is greater than the frictional force. If you apply the force greater than the frictional force, you can change the position of that object. If you apply the force which is less than the frictional force, the object does not change the position. So this concept you have to understand very well. If you apply the force which is greater than the frictional force, you can change the position of an object. If you apply less, or the force which is less than the frictional force, the object does not change the position. Okay. Now we are going to discuss very important point, Newton's laws of motion. Sir Isaac Newton made 3 laws. They are Newton's laws of motion. And in previous class, you have studied about the equations of motion. Okay, and now you are going to study Newton's equations, Newton's laws of motion. Right? Newton made 3 laws, like Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. But for today's class, we will discuss only Newton's first law of motion. So we are going to discuss about Newton's first law of motion right now. And there is other name also for the Newton's first law of motion, that is Newton's law of inertia. There are 2 names for the first law. One is Newton's first law of motion and the second is Newton's law of inertia. Okay, so before describing about the Newton's first law, you have to know about inertia. What is inertia? Inertia is the natural tendency of an object to continue its state of rest or uniform motion. For example, if you watch the TV, you have the tendency to continue that. That's a natural tendency of a human being. When you do one work, we have the habit of continuing that. Like, when you listen to the music, we have the habit of listening the music. When you sleep, you wish to sleep for more time. Right? So when you read some novels or like some magazines, we have the tendency to read that. So inertia is a natural tendency of an object to continue state of rest. State of rest means what? Tendency to continue state. Continue the rest, like not moving. When you are sitting somewhere, you wish to sit there itself, right? So that is tendency to continue state of rest or uniform motion. Uniform motion means what? If you are moving or if you are doing some work, you have the habit of doing that, right? So inertia is a natural tendency of an object to continue the state of rest or uniform motion. So that natural tendency of an object is known as inertia. So inertia is the natural tendency of the object to continue their works, like whether they are at rest, they wish to continue at rest, or whether they are doing any work, or whether they are moving. So they have the habit of doing, continuing that. So it's a natural tendency of an object to continue state of rest or uniform motion. And there are two types of inertia: inertia of motion or inertia of rest. Inertia of motion means tendency of the object to continue that motion. And inertia of the rest means the tendency of the object to continue the state of rest. If the object continues in uniform motion, that is inertia of motion. If the object continues at state of rest, that is inertia of rest. With the help of that, we can define our first law of motion or law of inertia. For example, I told you, when you sleep, you have the habit of sleep till your mother slaps you, or till your mother call you, or till your mother pour water on your body. Right? Till that you sleep continuously. When your mother, shout, get up, suddenly you will get up, right? Or when your mother slap you, you suddenly get up from the bed. So this snapping or calling or pouring water on your body is a compulsion from outside, or it's a force from outside. Till that you will sleep. Or we have that habit of setting alarm, right? Till the alarm rings we sleep, right? So that setting alarm is an outside force. So how we can connect this into our first law of motion? First law of motion states that an object continues or an object remains in a state of rest or uniform motion unless compelled to change that by applying force. An object remains in a state of rest or uniform motion unless compelled to change the state by applied force. See, an object remains in a state of rest. Remains in a state of rest means when you are sleeping. So an object remains in a state of rest or uniform motion unless compelled. Compelled to change means you slapping of your mother or alarm. So unless compelled to change that state by applied force. Which means we have the tendency, or an object have the tendency to continue its state of rest or uniform motion unless compelled to change that by the applied force. Like when you watch the TV, you wish to watch that programs till your mother switch off the TV. Right? When you sleep till your mother calls you or slaps you. So this is a tendency of an object. Okay. So Newton's first law of motion state that an object remains in a state of rest or uniform motion unless compelled to change the state by applied force. So we continue that unless somebody is compelling us. Right, so we persons will do a work unless if anybody is compelling us, right? So that is Newton's first law, and that tendency of an object is inertia. So you can say this as also law of inertia. So what is law of inertia? The object remains in a state of rest or uniform motion unless compelled to change that state by applied force. It's very important for you. Okay, so an object remains in a state of rest or uniform motion unless compelled to change the state by applied force. An object remains in a state of rest or uniform motion unless compelled to change that state by applied force. That is Newton's first law of motion or law of inertia. So, according to Newton's first law of motion, an object remains in a state of rest or uniform motion unless compelled to change that state by the applied force. That is the statement of Newton's first law of motion or law of inertia. Now, we are going to discuss some experience or some examples that we come across in our daily life. Like, you consider you are traveling in a bus. You are traveling in a bus and you are sitting in the seat. You continue that sitting till the driver apply the brakes. Correct now? You will be there in that seat till your point reach or till the driver applies the brake. When you applies the brake, suddenly you will move like this, right? So that is due to inertia. So when we are inside the bus or when you are sitting in the seat, we tend to continue that sitting till the driver applies the brakes. That is due to the natural tendency inertia. Right, so we wish to continue that journey, so that is the natural tendency. So when the driver applies the brakes, suddenly, there will be some movement like this, right? So that is due to inertia. Another case, what is the use of, safety belts? Why we are using the belts while we are traveling? Because when the driver applies the brakes, there may be the chances, we go and hit our head on the, panels or the glass in front, right? So we are moving to, just moving forward, right? So that moving forward may cause us injury on our head. Correct now? So in order to avoid that injury, we can wear the seat belt, and the reason or the cause behind this is due to inertia. So that is the inertia of our body, first we move forward, then we come back, right? We go like this and we come back. So that is due to inertia. So only the answer for this is inertia. That's why we have to wear seat belts to avoid this type of injuries due to inertia. Got it now? And another very important examples, while you are standing, like, while you are standing in the bus, you may feel that, while the driver applies the brakes, suddenly you move backward, right? You are moving back and coming. Why? While the driver applies the brakes, how our body moves? We move forward, backward, and will come back forward, right? First we move backward, then come back. Why? Because, on applying the brakes, what happens, you see, on applying the brakes or that application of brakes brings motion to our feet and also to the bus. On applying the brakes or application of brakes brings motion only to the feet as well as bus. And the rest of our portion, rest of our body means what you see, the upper portion, still wish to continue that state of rest. Only changes or only that application of force brings motion to our feet and the bus, not to any other parts. So our rest of our portion still wish to continue the state of rest. So in order to attain that state of rest, first our body moves back, then come back. So the reason behind this is inertia. And the reason behind this inertia. Why our body is trying to attain the previous state by moving back and coming forward. Why? Because by applying brakes, that's application of the brakes brings motion to our feet and the bus, not to our rest of our body. Okay, and another case, while playing the carom board, while you are, giving a kick, you may notice that only the lower coin changes the position and other coins, falling down. Why all the coins, you have to place the coins one by one, right? So by giving the kick, only the lower coin changes the position, rest of the coins fall vertically or fall down. Why? Because you are giving force only to the lower coin. Other coins wish to continue their state, so they fall down. Only the lower coin moves. Got it? Why only the lower coin changes the position? Because you are giving force to the lower coin, not to others. So the force you gave to the lowermost coin, so that coin changes the position, rest of the coins fall downwards. And you can see other situation in your textbook, like you have to take a card and place a coin over it, right? On giving force to the card flows off while the coin falls to the glass. Why the coin falls to the glass? Why the card flows? While you are giving force to the card, only the card flows off and the coin falls to the glass. Why? Because you are giving force to the card, not to the coin. You are giving force to the card, not to the coin. Coin wishes to continue its state of rest. Coin wishes to continue the state of rest, so it falls down to the glass and card flows off because you gave force to the card. So all the cases are the examples of inertia. And also there is one more example. While you take the turn, when you are traveling, while you take the turn, okay, we are moving to one side, right? And if we are moving to one side, right, so that moving one side also is a example or is a reason is inertia. So inertia is a natural tendency of an object to continue its state of rest or uniform motion, and we can come across many examples in our daily life. When we do some examples, you can see the influence of inertia there. So inertia is the natural tendency of an object to continue its state of rest or uniform motion, and the statement of Newton's first law of motion is that the object remains in a state of rest or uniform motion unless compelled to change the state by the applied force. And the last point of today's class is inertia and mass. How we can connect inertia and mass? What is the relationship between inertia and mass? How inertia and mass is connected? See, inertia is directly proportional to mass. Inertia is directly proportional to mass means what? If there is any change in the mass, you can see that change in the inertia. So if there is any small change in the mass, it affects on inertia, which means inertia is the measure of mass, or mass is the measure of inertia, which means heavier or more massive objects offers greater inertia, or lesser or smaller objects offers lower inertia. For example, small stone and big stone. Which is difficult to move? Definitely big stone. Big stone is very difficult to move now, because big stone, more mass, more inertia. Big stone, more mass, more inertia. Small stone, small mass, small inertia. So heavier objects offers more inertia, lower object or lighter objects offers less inertia. If the mass is more, there is greater inertia. If mass is less, smaller inertia, which means inertia is directly proportional to mass. If there is any change in the mass, it affects in the inertia, and mass is the measure of inertia. Which means heavier mass offers more inertia, lighter mass offers less inertia. If the object is big or more mass, more inertia. If the object is small, small inertia. Okay, so that's all about today's class. We have discussed very important points in our today's class. So understand this and by heart the law, and all the points, keep it in your mind, and we will meet you soon with another video. Until then, it's bye. Thank you for watching. Have a wonderful day ahead.